So the questions, again, another probability question. So here we've got, there are n counters in a bag. So we already know the total number of counters for this, which is perfect for us because that's going to help us to solve this question, because that denominator is going to be n, right? So you've got n counters. So both of these branches are going to be out of n. And then you've got, it says 4 of them are red. So straight away, you know, 4 counters are red. So the part that we need to work out algebraically is, oh, if there are 4 reds and there are n counters altogether, there must be n take away 4 blue counters. And so n take away 4 is our numerator for the first branch of blue. And then we've got another branch, because it says the probability of Ross that takes out 2 counters that are blue is a third. So really, I'm just going to focus my efforts on blue and blue. And so for me to work out the second branch of blue, I know there'll be 1 less counter, so it'll be n take away 1, and there's 1 fewer blue as well, right? N take away 4 was the number of blue. Now I have to take away another one, which is n take away 5, as the probability for blue now is n take away 5 over n take away 1. Now my reds doesn't change, so I would have 4 over n take away 1 here. Because there's 1 less counter altogether, so it'll still be n take away 1 for denominator. I don't need to work that out, but sometimes in questions you might need to work out all 4 of the branches. So now I've got the branch for blue and blue. I know this is going to equal to a third. Now, as we know, to work out probability with tree diagrams, for blue and blue, we're going to multiply the probabilities. So here we're going to do n take away 4 over n multiplied by n take away 5 over n take away 1, and that is equal to a third. It looks complicated, but one of the things, and I've seen it so many times, that students look at the question and kind of give up straight away. Now, you know, you've got the skills to do most of this, if not all of it, but the look of it puts you off sometimes. And so this is just a fraction multiplied by another fraction. What do we know about multiplying fractions? We multiply the numerators and denominators, right? So that's exactly what I'm going to do. N take away 4 multiplied by n take away 5 all over n brackets n take away 1 is equal to a third. That's all it looks like. Now we don't have the multiplication as such, we've just got 1 fraction. And so we can expand and we can kind of simplify. So I should get n squared take away 9n add 20 all over n squared take away n is equal to a third, right? Now it looks even more simpler, but we've got 2 denominators here. So we've got a denominator here, n squared take away n, and we've got 3 on the right hand side as our denominator. And so I need to eliminate these denominators to make my life easier, right? To simplify, to solve the equation, because at the end of the day, it does say show that n squared take away 3n plus that equals 0. It doesn't have any denominators there. So my instinct is I need to get rid of the denominator because what I'm trying to show doesn't have any denominators. So I'm going to get rid of the 3 first, right? So I'm going to multiply 3 on both sides. That means a third times 3 is a whole, isn't it? So that's why I cancel this 3 out and I'm left with a whole on the right hand side. And because I'm multiplying by 3 is the same as multiplying by 3 over 1, right? So really, I'm just multiplying a fraction, n squared take away 9n plus 20 over n squared take away n by 3 wholes, which means it's just 3 brackets n squared take away 9n plus 20 all over n squared take away n. So now I've only got 1 denominator. So now I'm going to multiply by n squared take away n on both sides to get rid of this. And I'm left with 3 brackets n squared take away 9n plus 20 equals n squared take away n. And so the next step for me is I want to try to get everything on one side, right? Because if you see what it says, to show that n squared take away 3n plus 30 equals 0, I need to make this equation equal 0, right? So the first thing I'm going to do is I'm going to try to expand this out. So I get 3n squared, take away 27n plus 60 equals n squared, take away n. If I subtract n squared and add n, then I have 0 here. And so I'm going to subtract n squared, and then I'm going to add n as well. And so I have 2n squared, so I'm going to subtract n squared, and then I'm going to add n, and I have negative 27n, or take away 27n, and add n is take away 26n plus 60. And now I've got something that resembles, something that resembles what I want, because it equals to 60, right? It equals to 0. And so I've got something that equals to 0, just like here, but it seems like this is 13 and 30 and 1n, whereas I've got 2n, 26 and 60. So it might seem, what do I do next, right? But the key is not to panic. You know that I can factorize this, right? 2n squared, take away 13n plus 30 equals 0. And so this is 2 times the bracket. So in order for me to eliminate the 2, I'm just gonna, did I do the right thing there? I'm gonna divide by 2 on both sides. And so that cancels this out. 0 divided by 2 is still 0. And you're left with n squared, take away 13 and add 30. And so that's how I've just shown what they wanted me to show, which was show that n squared take away 13n plus 30 equals 0. I've done that here, and that's my 5 marks. It's 5 marks, but you can see why, because there's a lot of working out here, right? And so that's why it's going to be 5 marks. Now the last part was to solve for x, and so n in this case. So here we can easily factorize, right? We've got n squared take away 13n plus 30. I need to figure out 2 numbers that give me 30 when I multiply, and add to give me negative 13. So I know negative 3 and negative 10, negative times negative is going to be positive. That will give me 30. Negative 3 add negative 10 is going to be negative 13n. And so this is what I've got. So what we're saying here is 9 take away 3 equals 0. And therefore n take away 3 equals 0. And n therefore must be equal to 3. Or n take away 10 equals 0. And therefore n must equal to 10. So we've got 2 answers. N equals 3 or 10. But in this question, n can't equal 3, can it? We can't have 3 as our total because we've already got 4 reds. That wouldn't make sense. And so n must be equal to 10. So at the end, we've only got one answer. N equals 10 is our final answer. Okay, we can't accept n equals 3 because it wouldn't make sense for this question. So that's how we would solve this question. It's a bit of a challenging question because there's a lot of working out, as you can see. But it's definitely doable, it's definitely possible, and you've got all the skills to do it. It's just taking a systematic approach and not panicking when you see a fraction with algebra, or you see denominators that you're finding hard to get rid of. So don't panic, and let's have a go at question 7 and see if you can solve that one by yourself.